Today we are doing the control practical for chemistry number 4, which is electrolysis of copper sulfate solution. And what I'm going to do is run through the method of how we would carry out this experiment and how you would collect the results. Initially, what we are going to do is start off with 2 copper foils, okay, and we're going to use these as our electrodes. I have some sandpaper here. What you need to do is just run the sandpaper over the copper so that you can clean off the copper foil electrodes, okay. Once you've done that with both of the electrodes, then you will need a sticky label, okay? And on top of the electrodes, stick the sticky label and just label it as the anode or the cathode. So I'm just going to put an A to represent the anode and a C to represent the cathode. Okay, once I've done that, the next job that I need to do is to weigh the mass of these electrodes. So as you can see here, I have a weighing scale, okay? So what I'm going to do is turn the scales on, and then I'll take my anode and place it onto the scales and record the mass. So here you will have one of these practical books given to you at the start of the course. You can see that there is a table of results in here, and you can see there's a column that says mass of the anode at start and mass of the cathode at start. So what you need to do is record the mass of the anode in there. So you can see here that I have a mass of 4.6. So in this column here, I would record 4.6 as my mass. I then do the same with the cathode. So I would take the cathode, place it onto the scales and record the mass of that as well, which is 4.7. You should already be provided with this when you start your practical, and this is the beaker of copper sulfate solution. So when you are using this, it's really important that you goggle up. Okay, so goggles up. Now, copper sulfate solution is an ionic compound which has been dissolved in water, so it does allow electricity to flow through it. Now, what you need is 2 wires, and they will both be put into this power pack, which has been plugged on, okay? Now, you can see that on the power pack there is a positive sign there and a negative sign there. So that means that this positive will be my anode. Okay, because remember, positive anode, negative is cathode. So I will then place the crocodile clip onto the anode. Okay. Then I take the cathode and I connect that up to the negative crocodile clip, like so. Okay, so now I have 2 of my copper foils that are connected to the wires which are wired up to the power pack. Once you've weighed out your electrodes, what you need to do is connect them up into a circuit. Now, in the control practical book that you have been given, they show you how to set up your circuit. Okay, now you can see that at the top bit there I have my power pack supply, which is this here. Okay, so this is what will be supplying my experiment with the power that it requires. You can see in the practical book that it says that I need to set the power pack to 6 volts. So you can see on here there is a dial. Okay, what you need to do is turn the dial so that it is on the 6 volts. Once you've done that, then the book says that the power pack is connected to a variable resistor, because that is the symbol for a variable resistor. So you can see here that I have a wire that leaves from the negative side of the power pack, okay, because there's a negative sign there, and it is connected up to the variable resistor, because this is a variable resistor. You can move this bar across to change the resistance in the power. Okay. I then have the other side of the variable resistor connected to my cathode. So once the electrodes have been weighed out, we place them into the copper sulfate solution, like so, and we turn on the power pack. Now, the book requests that you take readings for 2 amps, 3 amps, 4 amps and 5 amps. So we have to adjust the variable resistors so that we can get a reading on here of 2 amps. So you need to take that down, so slide it down, okay, and then we'll slide this out the other way. So we've got this one down to, sorry, just a little bit higher. Okay, we've got this down to 3.0. It will keep changing slightly, but as long as it's around 0.3, that shouldn't matter as much. So this then needs to be left for 20 minutes in the solution. Once it's been left there for 20 minutes, then what you do is you will take the electrodes out of the solution. Okay, so obviously I will not leave it for 20 minutes because we don't have that time, but you guys would have to start a stopwatch and time how long it takes for it to be inside the solution. Once it gets to 20 minutes, then you you turn the stopwatch off and you turn the power pack off and you remove your electrodes from the solution. So first of all, I'm going to remove the cathode. Okay, so to do this, I have to wash this with water, sorry, preferably distilled water. And then place it into the propanone solution. Okay, so dip it into that. Okay, then you would dry it's already dry. Okay, if the propanone doesn't evaporate, it is quite volatile, so it should evaporate very quickly, but if it doesn't, then you can dry it with a paper towel. Once it's dry, you then place your cathode onto the weighing scales and you record your new mass in your table of results. So in your table of results, in this bit I would put 0.3 amps because that was the amp reading on the ammeter, and then that would have my mass of the anode, sorry, that would have my mass of the cathode at the start, which I recorded, and then I would record the mass at the end here of 2.4 grams, and then you'd calculate your change in mass for the cathode. You then do the same for the anode. So you remove the anode out of the solution and you wash it with water, and then you place it into the propanone solution. Okay. Again, the propanone solution is very volatile, so it should evaporate. If it doesn't, you can dry it with a paper towel, and then you place it on the weighing scales and you weigh out the mass of your electrode. And you record that into the mass of the anode at the end. Okay. Then you need to repeat the experiment again, doing exactly the same technique that I've used in the previous one, but for a different current. So we've just done 0.3 amps, so we will change it to 0.4 amps now. Okay. So I don't need this bit. Okay. So you need to start off with measuring the mass of the anode and the cathode to begin with again. Okay. So I will place this onto my weighing scales, and that says that it's 0.3 amps. So into my book, under the second reading, where I would put the mass of the anode at start would be 3.3 grams. I would then put this and attach it to the positive side, because the anode is positive, positive anode. Okay. And then I would do the same for the cathode. So I place the cathode onto there, and I record the mass, which is 2.4 grams, into the table where it says the mass of the cathode at start. And then that would then be attached to and placed into the solution. I then turn my power pack on, and now I need to alter my resistor so that I have a reading on it of 0.4. So I will slide this, hopefully, oops, up. Okay. You need to get your reading as close to 0.4 as possible. So you can see that this keeps flicking between 0.38 to 0.9 to 0.4. It seems a bit temperamental today. Once that's done, you then start your stopwatch. Sorry. And you time for 20 minutes again, and then you'd repeat the whole process where you take out your electrodes, wash them with water, place them into the propanone, and then weigh them again on the weighing scales to write down their mass at the end.